Hi everyone, so today I'll be presenting my EM2 assignment. So firstly, my claim is that Americans eat an average of 2.8 meals per day. So to verify my claim, I gathered more data by asking Americans how many meals they eat per day shown here. My null hypothesis is that the mean average meals Americans eat is equals to 2.8, and my alternate hypothesis is the mean is not equals to 2.8. I chose this to be my alternate hypothesis because my claim states that the mean is only one value, not more and not less. This means that later on I'll be using a two-tailed test since my alternate hypothesis indicates a difference, not a direction. I gathered a total of 30 responses for my sample data, so I can use my sample to test my hypothesis here by finding the mean, standard deviation, the statistic, and p-value. My p-value will then tell me the probability of getting an extreme sample statistic in the direction of the alternate hypothesis. I'll use this formula because my standard deviation is unknown. So my sample mean is 2.53 using Excel, and my standard deviation is 0.681. And then my test stat using standard deviation and sample mean is negative 2.14, and finally my p-value is 0.0406. So then we can arrive at a conclusion by comparing the p-value and the significance level. Basically, if the p-value is less than the significance level, we can reject the null hypothesis. But if it's more than the significance level, we'll fail to reject the null hypothesis. So they've given us a significance level of 5%, which is 0.05. The significance level is basically the maximum probability of rejecting the null hypothesis, even though it's true. And since our p-value is less than our significance level, we will reject the null hypothesis that the mean average meals Americans eat per day is 2.8. So then lastly, I found the range that likely contains the true mean value by finding the margin of error also using Excel. So the range is basically the sample mean plus minus the margin of error, and the confidence interval is basically means that the range is 95% true since we have a 95% confidence interval. So at 95 confidence interval for population mean, the mean is more than 2.278877 and less than 2.787789. So that's it. Thank you.